See, this is the structure of artificial neural network. As we have discussed already, we have got the inputs, that is x1 comma x2, that is nothing but input, that is dendrites. Then weight, it is equal to synapse, that is w1 comma w2. Here weights w1 as well as w2. Y indicates output. Then we are having nucleus, that is a processing unit. So inside the processing unit, we are performing the function of called y. Here you know the formula is indicated. It is y is equal to x1 into wi plus x1 into w1 plus x2 into w2. And after that we have to apply activation function. That is the output unit is axon. So here you can clearly we can able to know that is nothing but input is dendrites. Then we are having the weight is equal to synapse. Then we are performing the processing, that is called soma or cell body. Then we have got axon. So first we have to take the input and we have to initially randomly we have to provide the weight, and we have to perform the output function y, and we have to calculate y is equal to xi into wi plus x1 into w1 plus x2 into w2. Then we have to apply the activation functions. As we have discussed already, we have different types of activation functions. Some of the activation functions we can apply only in the hidden layer, and some of the activation functions we can apply in the output layer. So here weight indicates the importance of the input information, and bias indicates an additional value which is used to activate the activation function. It provides the flexibility, it provides the large range of prediction values. Then we can say that is called activation function. Activation function means it introduces the non-linearity in the output. For example, if to know the complex pattern of the input signal, the activation function is necessary. Then only we can have the non-linearity in the output. That means to analyze the complex pattern, linearity is not enough. So we have to go for non-linearity. So this is nothing but activation functions. So different types of activation functions already we have discussed. So this is the characteristics. That is, there are different types of architecture in the artificial neural network. One is nothing but single layer feed forward, and next one is nothing but multi-layer feed forward, and next one is nothing but recurrent network. Single layer means there is a one input layer as well as one output layer, that is called a single layer feed forward. Then feed forward means so input, processing, output. So we have to do the processing, in forward direction. Then multi-layer means instead of one single layer, we are using parallelly multiple layers or different types of layers. So here also input layer. Then there are many layers. Then we have got output layers. That is nothing but multi-layer. Recurrent means we have to store the past data. We have to use the memory, and we have to store the past data, and we have to perform the comparison between the present data as well as past data to learn the fast value. That is recurrent neural network. For example, LSTM, then gated GRU, then deep RNN. These are all comes under recurrent neural networks. So that is another criteria. Then different types of learning algorithms. So there are three types of learning. So one is called supervised learning, and one more is called unsupervised learning, and one more is called reinforcement learning. What is supervised learning means? Here the learning can have some reference. That is, we can have the labeled data. Learning means labeled data. Here, for example, a teacher is delivering some lecture to the students. So students can able to understand, or they can learn based on the input of teacher. That is called label. Similarly, in the network, for example, suppose if I want to do a training model by having the, I am going to identify the tumor, then we can have the labels by tumor, no tumor, tumor, no tumor. There are group of images which comes under tumor, there are group of images which comes under a non-tumor. So this is a labeled model. There is nothing but a labeled model. So here a label is available to provide the guidance to learn the network. That is called supervised learning. Next one is in supervised learning only, we are going to study different types of network like simple perceptron, then we can say adaptive linear neuron, then we can say multi-layer adaptive linear neuron, then we can say back propagation networks. So these are all comes under supervised learning. Then unsupervised learning means it is just opposite to the supervised learning. Here the learning will happen automatically based on the prediction or based on the past value. So here automatically it learns, the network will learn automatically. It is nothing but there is no labeling data. So whatever the images we can give the input, then during the training process the network learn by itself. That means students can study for the examination without help of teacher. That is nothing but unsupervised learning. That means it learns by itself without any help of any label data or any reference. That is nothing but unsupervised learning. Then finally reinforcement. Here reinforcement means here the learning will happen with the help of feedback. For example, each and every time a teacher will provide the feedback. Oh, you are doing very good. You are not doing good. Like that, based on the feedback, it will adjust. Similarly, in a network, for example, robotics automation, robotic path finding, this kind of applications, a reinforcement learning is very useful. For example, a path detection, a robot is moving between the path, there is an obstacle is present. So what it will do, it will provide the feedback like there is an obstacle. So you please change the path like that. So it provides the feedback. If it is providing good feedback, then we can say it is good sign. If it is not providing good feedback, then the penalty will be introduced. Similarly, so based on this feedback, it is working. So it is called a reinforcement learning. So this is the different characteristics of the artificial neural network. So first one, different types of network. That is, one is called single layer network, and one more is called multi-layer network, and another one is called a that is recurrent networks. And based on the learning algorithm, we can classify that is supervised learning, then we can classify unsupervised learning, then we can say that is nothing but reinforcement learning. Then next, that is nothing but activation function. That is, it is used to introduce a non-linearity as well as used to compute the output signal from the input signal. The activation function is very important. So already we have discussed there are different types of activation function. It is nothing but relay activation function. Then we can have sigmoid activation function. It is unipolar sigmoid activation function. Then bipolar sigmoid activation function, also named as sandwich. Then finally we can say it is leaky ReLU, and one more thing is that is nothing but softmax activation function. So here ReLU can be useful in hidden layer applications, and softmax can be useful in output layer applications. So for binary classifications, we can go for sigmoid activation function. For multi-class classification, we can go for softmax activation function, because softmax activation function, whatever the values, if you are that is output provide based on probability. So if you are adding these three, the output becomes 1. That is nothing but softmax activation function. So these are the different activation functions which we are using in the network to introduce the non-linearity, otherwise used to calculate the output signal from the input signal. So these are all the different types of activation functions which we are using in the artificial neural network to perform the process of finding the output based on the input values. So this is about the activation functions. So next class we can discuss about different types of networks and different learning procedures, and how these activation functions are used, and how the error will be calculated, and how the learning parameters gets updated.